Today, we're announcing that Honcho has fully determined the Pareto Frontier of agent memory. We've achieved the top overall scores on 3 of the most important memory benchmarks: Locomo, Longmen, and Beam. But memory systems should be evaluated on more dimensions than just performance. Honcho is also the fastest, cheapest, and most token-efficient memory solution on the market. The Pareto Frontier means you can't improve on one dimension without sacrificing another. If you're on the frontier, you dominate across all the dimensions that matter. My name's Vince. I'm one of the co-founders of Plastic Labs, and I'm going to walk you through our benchmark results. But more importantly, I also want to explain why these benchmarks don't measure what actually matters for memory. So, one of the first serious attempts at evaluating memory beyond more than a handful of chat sessions was Locomo. It came out in early 2024, and in addition to longer chat sessions, its strength was introducing dimensions like connecting information across sessions and reasoning about time. But it has significant limitations. At an average of 16,000 tokens per dialogue, modern LLMs fit this entirely in context. Most researchers have abandoned the paper's dated and inconsistent evaluation methods for their own LLM as a judge prompts, and many of the questions are ambiguous or have debatable ground truth answers. For Locomo, Honcho is at the theoretical ceiling. Our remaining errors are almost entirely evaluation artifacts, with judges disagreeing about equivalent phrasings, ambiguous questions with multiple valid interpretations, and natural variance between generations. At a certain point, the benchmark is just too noisy. Then came Longmen, which dropped in February of 2025 and became the benchmark everyone started chasing. It built on Locomo's work, but focused specifically on chat assistance across a broader set of memory abilities. Longmen's key insight was the needle in a haystack design. Evidence is hidden across multiple sessions, buried in around 115,000 tokens of irrelevant conversation. The goal was to show that even as context windows get larger, LLMs experience steep performance drop-off when you fill them with noise. It's definitely better than Locomo. It's longer, more carefully constructed, and tests a broader set of abilities, but like Locomo, it uses this pass-fail scoring mechanism, which means you either got the question right or wrong. There's no partial credit or nuance, really. And again, like Locomo, once you're in the 90% plus range, most failures are judge disagreements. Honcho is state-of-the-art on Longmen, and again, we're at the theoretical limit. We can push the number up by tweaking prompts or models, but we'd really just be gaming the evaluation variance. And the final benchmark is Beam, which was released on Halloween of 2025 by researchers who saw the same limitations we did. Contexts were long, but not long enough to truly require a memory system. It comes in 4 size variants: 100K, 500K, 1 million, and 10 million tokens. Yes, 10 million tokens of coherent, single-user conversation with consistent narrative. Beam is certainly the most comprehensive benchmark. It tests 10 distinct memory abilities, spans multiple domains, and uses graded scoring instead of pass-fail, making it harder to ace with partial answers. If you really want to show off your context window or memory system capabilities, you should probably be using Beam. But even Beam shares a fundamental limitation with every benchmark in the space. They're all designed to measure how effectively an LLM uses its context window. Not memory systems, context windows. That's a valid thing to measure. Context windows do have real problems. Context rot happens when information at the beginning of the window gets ignored as the model attends to more recent tokens. Needle and haystack failures occur because signal drowns in noise when you fill the context window with conversation history. And it's also super sensitive to ordering. Move a key fact from turn 50 to turn 500 and watch the model fail to find it. These are real failure modes, which are worth studying and benchmarking. But here's the problem. These evaluations only tell you that the context window made mistakes. They don't tell you how or why. And for most of us, that distinction matters a lot because we're not the ones building these models. If you're OpenAI or Anthropic, knowing that your context window degrades at 100,000 tokens is actionable. You can go fix the attention mechanism. You can go improve your dataset and train on longer sequences. You can do something about it, but if you're building a memory system on top of these models or selecting a memory system to ship your AI app or agent with, that information is nearly useless. You can't fix the context window. What you can do, though, is control everything else. What goes into that window, how it's structured, what gets compressed, what gets retrieved, and how you reason about it before and after inference. Memory systems have an enormous design space. You can make improvements at every level of the stack to address specific failure modes. But evaluations designed just to test whether a context window messed up tell you nothing about the efficacy of your memory architecture. They can't tell you if your retrieval is working. They can't tell you if your compression is lossy. They can't tell you if your reasoning is sound. They tell you one thing: did the final answer match ground truth? That's simply not enough to build on. So what happens when everyone optimizes for these evals? You end up with a leaderboard where people present 1 to 2% gains as breakthroughs. But we've seen on Beam 100K, for example, that scores will swing anywhere between plus or minus 4% between runs with the exact same setup. A system scoring 0.62 and one scoring 0.64 are statistically indistinguishable. You get scores jumping around dramatically by swapping models, not improving methodology. A 3-point gain often means we use Gemini 3 Pro instead of GPT-4o Mini, not we built a better memory system. And you get absurd economics. Some systems hitting high scores are burning 50 cents to $1 per query. They're using frontier models with million token context windows for everything. That's great for winning a benchmark, but completely undeployable. You cannot build a business with reasonable margins on that stack. So why does Honcho score so well on benchmarks that measure something we think matters less than what we're building? It comes down to this. Honcho doesn't just store and retrieve information. It reasons about it. And it turns out that when you build a system that actually thinks about what it knows, you get really good retrieval as a side effect. We post-train small language models to do formal logical reasoning over conversation history. The system extracts latent information from data, conclusions that are only accessible through reasoning, not through keyword matching or semantic similarity. It tracks how things change over time. It identifies contradictions. These conclusions become the backbone of our memory. This is a general approach that lets us engineer the context window. Instead of stuffing 115,000 tokens of raw conversation into the model, we surface the 10,000 tokens that actually matter. Tokens that are pre-reasoned, compressed, and super relevant to the query. The LLM sees a clean, information-dense set of context instead of a haystack full of noise. That's why our token efficiency is so high. At long mem scale, Honcho uses about 11% of the available context, and at Beam 10 million uses 0.5%. We're not burning through 10 million tokens to answer a question. We're selecting the few thousand that matter. And that token efficiency cascades into everything else. Fewer tokens means lower cost. Fewer tokens means lower latency. And critically, fewer tokens mean the LLM can actually attend to the information. When you give a model 10,000 highly relevant tokens instead of 100,000 tokens of noise, it doesn't suffer from context rot. It doesn't lose the needle in the haystack. The context window works the way it's supposed to. That's the real insight. Reasoning lets you maximize the context window's effectiveness. You get better answers and better efficiency and better speed. Not because you're trading off against each of them, but because they all flow from the same source, and it's that reasoning. These benchmarks test basic memory. Can you recall facts from a conversation history? We think that's table stakes. It's the first thing any memory system needs to do. But this is not what Honcho is optimizing for. Honcho is a continual learning system. Every AI app or agent is going to need ways to learn about and retain state on users, agents, its environment, experiences, tasks, and more. That means going beyond context windows and naive storage and retrieval. It means reasoning to learn continuously over time. And that is what we're building Honcho to do. If you want to try Honcho, it's open source with a managed service at app.honcho.dev. If you want to use a stateful assistant built with Honcho, check out honcho.chat. All the details in regards to the benchmarks, token efficiency, cost, and speed will be included in an accompanying blog post. And finally, if you care about real long-term memory, about systems that actually learn, come build with us. We'll figure out what we should actually be measuring together.